Hi everyone. I'm amazed because it's kind of late in the event that so many of you are here, and it's kind of scary. I have to add to the other presenters who said it's scary. I've done a talk here before in one of the smaller rooms, but being on a big stage, it's kind of scary. I've chosen a colour scheme of white on black as well. I'm a bit concerned you won't be able to see things, so we'll see what happens. If it turns out you can't see the text, then sort of put your hand up or something and tell me, and then I maybe could interactively change the colour scheme of the whole presentation live. See how that works out for me. Yeah, so I'm going to do a talk on XP, Extreme Programming. My name's Mike Harris. I'm currently a software engineering lead, and I've been working on and off in software for about 25 years. And that's it, really. It's XP stupid. Anyone here knows where I'm copying something else someone said? Do you know where it comes from? It's a joke of, it's a pun on something else. Anyone? It's the economy stupid, which is credited to, oh, you see it doesn't work, does it? Anyway, technology. Okay, it's credited to Bill Clinton, who said it's the economy stupid. So I was paraphrasing that. Just to, I'd like to know, put your hand up if you're a developer. Okay, and keep your hand up, well, no, put your hand up if you're a tester, product owner, Scrum master, accountant, marketing, project manager. Oh, right, you're everything. Okay, good. Okay, it's just interesting to know how many of you are here. Okay, so my plan, basically, I'm going to introduce myself. I've done that. I'm going to explain why I think this is important, give you a bit of background. I'm going to introduce extreme programming. I'm going to outline some of my favorite practices that I think we should be doing, which are influenced by extreme programming. And I'm going to give you an example of applying it. And what I'm basically saying is that, really, which is if you're not doing XP, you're not being agile. I will say as well, just to test you, because this is really at the end of the conference, I've got about 37 slides with lots of bullet points on. Just for you. I know it's trendy these days to have one picture and one word, but I'm bucking the trend here. It's like a legacy slide presentation. So why this talk? Well, as I've said, that's it really. If you're not doing XP, if you're not doing those practices, and it doesn't matter really what methodology you're using to manage your project, like Scrum or Kanban or, I don't know, Six Sigma, you're not really doing agile software development. And so I came up with a couple of thoughts about things I've been on. This is a project, really from the outside, we've got an underperforming delivery team, experienced crew, they've been on the same platform for many years, got a massive backlog of unprioritized work. They were unavailable in the mornings, they had to do that because they had so much work to do. And the customer had no faith in the team. And there was a master developer who was telling everyone what to do and ordering them about. They had an unpredictable delivery, and they had a large spreadsheet with their backlog in of something called the grand scheme that they were going to do. And this is a team that wasn't agile at all, that we hadn't undergone it. And while I was there, we went through an agile transformation. And when you looked at that team from the inside, they had all those kind of normal practices. You'd think that a team were doing things the old way, all of the code was legacy code. There were no tests. It was a tightly coupled system. It was hard to change. There were dragon-infested areas of the code that you just couldn't change. It was too dangerous. Basically, the prioritization was whichever manager's got the biggest ego wins the job. There was no version control. There was one shared dev environment server for everyone. Dev was never like live. So that was a kind of bad project where there was no agile done, and we did an agile transformation and we improved things. And then I rolled on to a project that from the outside looked really good. So can you see that? Oh, you can actually. Great. So it was a high-performing delivery team, and there was an experienced crew. Again, they'd been on the same platform for many years. They had great relations with the customers. Excellent interpersonal relations with the team. They were all remote workers, but they got on really well. And there was a perception from the outside of fast delivery and on-time delivery. So all going well, really. They had a well-managed customer relations. And they have lovely cycle time graphs produced as well. And they had nice burn-up charts as well. It's great, like all this stuff. But actually, when we started looking at the inside of the project and looking at actually doing the software development side of things, we found that the same things. Almost all of the code was legacy code. There were no tests. It was a tightly coupled system that was hard to change. There were dragon-infested areas of the code. They had a BDD sort of style Selenium test suite that they built afterwards to test stuff, and it took hours to run, and thus no one ever used it. There was a lot of people in their project practices. There were a lot of sort of people writing stories and doing Scrum and testing it, and there had so many handoffs and stuff that everything would take quite a long time to do. The deployment would take up a day for them to plan the deployment and a day to do. And the production version of the code never existed in version control. There wasn't, because of the way the deployment was done. There's lots of siloed knowledge. Certain people knew about certain things, and they had a dedicated sysops that didn't really understand the application that they were doing. So there's a lot of blocks there. And the conclusion I had from that is, and I had some other project examples, but I've cut them out of this to fit it in. But my conclusion from that and other things I'd seen was that you get a load of people like that on a development team, and they've got a board with loads of stickies on it, and you walk through their office and look at that board with all the stickies on it, and they've got these graphs that show how much they're delivering. But the reality of it is, quite often behind the scenes, they've still got the spaghetti code problem. They've still got the areas of the code where there are dragons. The developers often are sort of at pains to have pains working. Does anyone have that problem? Does anyone have that problem? Or you're all kind of transformed? Wow, okay. And anyone know where that's from? No? Okay. That's, what is it, 1970s television series called Ever Decreasing Circles with Richard Bryars in the middle there. So it feels like, although they'd applied the Scrum practices, it feels like they were just going around in ever-decreasing circles, and things really weren't improving. And so what I felt about was, this is quite a commonly drawn model with XP in the middle of software development with something like Scrum around it. And that gives us our agile and lean software developments. But the problem is if you're not doing the test-driven development stuff, if you're not doing the pair program, if you're not doing all this stuff, then that kind of goes away. And you're not doing that stuff. And so really, what I'm saying is that. And that is what is happening. And so you've only got Scrum, or whatever. So I'm going to do just a brief recap on XP. So what I'd like to know is, put your hand up if you know what XP is. Right, okay. Keep your hand up then if you think you're using it in your organization. Right, okay. So, okay, there's about 6 people or something. So who's using Scrum? Oh, okay, not many. Kanban? Prince 2? No? Okay. Scrumban? What's everyone else doing then? Just chaos, is it? Okay. Hey? You make your own one up, don't you? Yeah, everyone's doing their own thing, aren't they? So quickly, I'll recap. Kent Beck, there he is, was working for Chrysler on this payroll system, and he became the project leader, and he refined the methodology that he applied to the project and wrote this book called Extreme Programming Explained. Who's read it? Put your hand up. A few of us. Okay. It's a sort of seminal book, really, in modern software engineering. I recommend it. So he wrote that book, and it was published in 1999, second edition 2004. And one thing is he didn't invent all the stuff in the book, he just codified it into a methodology that he called extreme programming. So some of it, like TDD, the oldest recorded example of it is in that book, which is Digital Computer Programming by Daniel McCracken, and that was written in 1957. So it's quite a long time ago. It's older. That guy wrote that book as well, So this is a long time ago that this has been around. So XP, we got some values. We probably, it's a way of representing them. So we've got communication, simplicity, feedback, courage, respect. So those are the values that XP holds true. There's a lot of overlap in a lot of other things, in Lean, in Agile, in all sorts of different things. XP's got a load of principles, and I'll run through these quickly. Otherwise, we'll be here all day. So here we go. Humanity, economics, mutual benefit, self-similarity, improvement, diversity, reflection, there's a lot of them, isn't there? Flow, Woody was talking about flow earlier on. Opportunity, redundancy, failure, quality, baby steps. I think there's one more. Accepted responsibility. I think they're really good principles. I'm not going to go through them all. And it's got some practices, and these are really what we're going to look at today. So this is what Kent Beck came up with in '99, refined in 2004. Squeaky, isn't it? So co-located teams. He said, whole team is involved in everything. Having a formative workspace. Now, we're doing these things. I realise that we are, we've got our boards, we've got our build monitors. Energized work, pair programming. Stories, a weekly cycle. That's what he defined, which, loosely is an iteration. A quarterly cycle, as in releases, or at least planning a little bit a quarter ahead where we're going to go, but no more than that. Building slack into the system so that everyone isn't just working flat out all the time. That's really important. If you're on a development team and you get to 5 o'clock and you're supposed to go home, but actually it's worth doing another hour because you really got to get that finished, and you're doing it the next day and the next day and the next day and the next day, and that becomes de rigueur, you've got no slack in the system. A 10-minute build. Yeah, that's pretty useful if you can build your software fairly quickly. Continuous integration. Test-first programming, which we now call test-driven development. And incremental design, which I guess we call iterative design and other things. Okay, put your hand up if you're doing all of those in your team. Wow. We have 1 star over here. What's it like?
It's amazing.
There you go.
We've had 0 turnover in 4 years.
0 people leaving or coming.
But we've
People come, but no one's left. Yeah. I didn't put my hand up. You noticed that, by the way. So that's a while ago. That's in 2004. Recently I've been on a project which I really enjoyed, and we were doing some great practices, and what I'd like to do is share what we were doing, which some of it covers stuff you've seen, some of it you might not have seen, and I want to go through how they benefited us. So this is 12 things that I came up with that I've been doing that I think is really worth doing, and just talk through them. So first of all, I'll list them. Pair mob programming. We had Woody Zool here this morning, the mob programming guy. We had test first and test right development, which I'll go into. Tiny tasking, self-documenting code, trunk-based development. That's contentious. Systematically checking assumptions, minimum viable product, intelligent technical debt, automated deployments, Testers are developers, another contentious one. Know your tool. You could interpret that in several ways. And regular feedback. So let's go through them. How are we doing for time? Yeah, all right. So pair mob programming. This is obviously, can you see that all right? The founder of pair programming, Kim Jong-un, there. So who is doing pair programming? Put your hands up. Regularly, yeah, basis. Mob programming, I know Woody Zool asked that. Okay, so there's a sort of mob, are you the actual mob that does the mob programming at the back? Okay, look at, see, they even do mob conference attendance. And you've brought your accountant come marketing person with you as well in the mob. That's very good. So we know this, 2 or more people share the keyboard. You take it in turns to be the driver. You swap every, 10 to 20 minutes. Or actually whenever it feels right. I've done it sometimes and it's actually, it feels right for someone to continue because of the way you're doing it. I think that's fine. I think it's really important to take breaks when you need to take breaks. Whenever that is, if you just need to stop, then just stop doing it. I know people, you say, we've got to do pair programming. They're like, I've got to do pair programming. And they just keep doing it until they're sweating and they really hate it, and don't do that. Yeah, if you're doing mob programming, mob Googling kind of sucks, in my opinion. Like mob cluelessness. If you're doing like something new and you really don't know what it is you're trying to do. Say you're doing a new technology. Say you're going to use Amazon Kinesis for something, and none of you have ever really looked at it. Don't try and work it out together. That really is, I find that really difficult. Do break off, maybe. Say, hey, I tell you what, we'll all spend the afternoon finding out about this, and tomorrow morning we'll come back and then we'll work on it once we've learned something about it. If you've got stories which are longer than a few days and you're pairing, this doesn't apply to mobbing, obviously, I do recommend rotating on and off stories. Some people hate it because of context switching. I think it's really good because it's really, and handoffs can be a problem, but I think it's really good because you get more people knowing what's actually happening and you get different points of view. If you do mob programming, also holding a retro is a good one. Is like at the end of the day, spend 5 minutes saying, how was it for you? And with this, I find it really useful to have a charter. So from our retros, we came up with a team charter about how to engage with it. I'm sure if you buy Woody's book, then a lot of that stuff's in there. So, test first, test right development. Who does test? Is there anyone who doesn't do test-driven development here? Put your hand up. Okay, cool. Have you got a good? Why? Is anyone a volunteer? No, because there are some really good technical reasons, like certain things. I know with certain embedded systems and stuff, it's very difficult to do. Anyone want to volunteer? I'm sorry to put you on the spot, actually.
So, I know a reason why some of the developers I work with don't, and that's because they work on mobile, and so running the test is so bloody slow that they just get really angry, and angry developers don't write great code.
And break the mobile phones they're trying to test in the process, probably. Yeah, okay, there are some valid reasons. So we all know we know what it is then, because we all mostly do it. We write the test first, we write the code to make the test pass, we refactor it, repeat that cycle. The important thing is to test at the most appropriate level of that test pyramid. And that's quite important, and that's what I mean by sort of test right, because obviously if you're too far at the top, then everything takes too long to run your tests. That's not so good. However, sometimes, especially if you're building like a decoupled system, you've got a lot of stuff around integration, so you may need your test further up the pyramid. I think that's important as well. Ensure all code's tested once. So it's like, if you've got some tests around this piece of code, you don't necessarily, unless it's about integrating that code, you don't need to have it repeated in lots of different places, which I see often. Obviously, we know that unit tests are faster. And also try not to do defensive programming. If you've got, I know one of the things is the tendency to write tests that are like, okay, well, we must test that if we pass a float to this function, then it's going to return a reasonable response. Well, if the consumer of that thing that you've written as well is never going to send it a float, I'm not sure that that's useful to do that kind of thing. It's not sure it's test drive that. We've got a tendency to over-engineer in a defensive way when we write code. And another thing is, I've noticed, especially I was working on a microservices kind of decoupled project, and we ran some code coverage tools to see that we had all our code tested, and they can be very misleading because you can't, or they find it can be quite difficult for them to work out whether a code is tested. So it would come up with a report saying, oh, you've got quite low code coverage. If we went to the code, we could find the test that executed the code. So it's just beware of that. Right, so that's kind of stuff that we know about already, and I hope, and you're all, well, you know, most of you are doing. Okay, tiny tasking. Who's heard of this? Put your hand up. This is quite exciting. Yeah. So you've got a story, and hopefully your story is quite small, and you're pairing with someone. And what we practice is sitting down and thinking about what we're going to do. You might do this in lots of different ways, and writing it down and agreeing before you do it. So it could be like in the morning you're working on a particular piece, and you want to say, well, this story, how does it break down? What are we going to do with it? So it's about breaking the story into baby steps, but these aren't like stories on a board, because you don't put stories on a board to the nth degree. You plan out and agree. You're going to pair with someone, or you're mobbing with a team, and you sort of plan this out. You put a critical path for what you're going to do. I've got to write this test. I'm going to write this bit of code. I'm going to add this deployment script, whatever it is, and that's my task. Try and get into the correct level of detail. So, for example, if you've got too much, you've got too many of them, you might have done too much upfront planning, or you might have a story that's really large, or your little tasks are too small. And the benefit of this is you've agreed in your pair roughly what you're going to do, and if anyone else new rolls onto the story, you've got that laid out. They know where they are. They can see, oh, right, you guys have done that bit, and now this is the direction you're heading in. And it makes that swapping really easy. An example is much easier to show you, and there's an example. So this is us trying to deploy some S3 Lambda thing in AWS, and you can see that what we've done is we've written so along the top, you've basically got the top level stories of what we were doing. So that's your sort of critical path, and then down are the details to do with that. You could do it any which way you want. We had a pile of Post-its. It's probably the best way to do it. You could write it down. I really like it. It just helps you keep track of where you are. You could go away, you could say, I'm going to break off, I've got a meeting, and your pair is there, and you know what you were going to do, and you can come back to it after the meeting, and you can see how well that's progressed. So I like those. Oh, it's gone the wrong way. Here we go. Write self-documenting code. This is an old one again. We all should be doing it. Who does it? Put your hand up if you write self-documenting code. Brilliant. So we need to write more self-documenting code, obviously, people. So it's really important. I think comments should document whys, not whats and hows. Yeah? If you've got something that says, this is done because there was this, I've got this Stack Overflow article, or this bug tracker thing that says, this doesn't actually work properly, you have to do it like that, that's a great comment. But if it's the kind of comment that says, this is going to add two numbers together, silly example, it's pointless. It's a waste of time. So try and make your code be self-explanatory so you don't have to write comments around telling people what to do, what it does. So therefore use meaningful names for classes, methods, variables, and that kind of thing. Also that thing, if you're mobbing or pairing, those mobbers up there, do you have problems like when you're going to write a new test method or a method or something? And you're sort of all there going, should we call it should do this, or is it this or that? And you can get a real block on that. I guess, I don't know whether you guys do this, but we always just call it foo until we know what we're trying to do, because we don't always know what we're trying to do until we get there. So maybe just call something a foo and then work out what it's for. Apply those solid and clean code principles if you can. Some of them are slightly esoteric, and some of them aren't always appropriate. Who's read Clean Code by Bob Martin? Cool. That's good. Good book. Clean Coder. Who's read Clean Coder, actually? The follow-on. That's a really good book, I think, because it's really about your sort of mentality and attitude as a developer. Right. Use your IDE. If you've got a good IDE, it has tools to help improve your code readability, like refactoring tools and stuff like that. You should use it. Get a better IDE. If your IDE doesn't really allow you to refactor well and that sort of thing, get another one, because it's not the right one. So there's Rule 11 about that. So trunk-based development. Who does trunk-based development? This is like a question. And okay. I think trunk-based development's great. It's difficult sometimes to adjust to it. So the idea of it is that everything we do, there's a whole talk in this, isn't there, really? Everything we do should be production ready. So the code we're working on in dev is ready to go into production. And our aim is to merge to the trunk as soon as possible. Yeah? So we don't deviate away from what our production code is. And maybe we can do that multiple times a day as well. And when we were using branches, they generally survive overnight only. As in, we haven't finished what we were doing at the end of the day, and we couldn't push to the trunk or the master, and therefore we needed just somewhere to put our work in progress. So we'd create a commit saying work in progress, end of day, whatever it is, commit the code, and then the next morning we just delete it. In fact, we just unstage our commit from there and just go back to master and carry on, go back to the trunk. So you can get around the fact that you're always working. It's not always possible. I realize that you might have a really big, different piece that might make this not possible. So like all of these things, I've done them. They weren't always appropriate, but I think it's a goal to go for. They're good things to try and do. You may not do all of them. So to get around the fact that you're always on master, we were using expand and contract techniques. So like, for example, support both types of functionality and make that bit, get that live, and then go back and get rid of the thing you were replacing. Another one, which I haven't put on here, is like feature toggles, feature switches, and that kind of thing. You can have production code and then have a way of switching that code on. Who uses that method for rolling stuff live? Yeah, that works quite well with that sort of trunk-based development where you want to switch on a new piece of functionality. So we know that sort of experimental spike branches, here's an exception, may live a little longer. So you can use them to experiment with a whole new way of doing things or a whole thing you've never done before. But if you do that, they should be as short-lived as possible. So what we found was a pitfall we'd fall into is we're doing some analysis. So what had happened was the devs had come along. We got, hey, right, we've got to analyze this new thing. We've never used Kinesis before. Let's write these classes. Let's mess about. Let's try and connect it up. We wouldn't have any tests necessarily. And we'd put it on a spike. And then we'd done the analysis, and then we'd make that the production code, and then go back and try and write tests. And it would be full of bugs, and that really wasn't a good idea for us. So I think if you do that, it should never become production code, that kind of code. That's your analysis, and you want to go back and you want to do your test-driven development and start again and write some good production-worthy code. So systematically check your assumptions. This is a technique used like when you get stuck on something, you've got a problem, there's a bug, something's not working, no one can quite work it out. And this is really obvious, I think, in a lot of ways. It's just about working through how to solve it, not reacting. So you get stuck, maybe you pair with someone, maybe you swarm on it because it's really important, you need all the minds there. And just use a whiteboard and ask each other what it is you know and what you don't know and what you think you know, and check all these assumptions. very often I find what happens is, I've done it many times, and you go, all right, this isn't working. That's because that thing, I reckon it's that over there. And then spend like 2 hours trying to solve that problem over here, and it turns out not to be the problem. And you just end up stressed, more stressed, and spinning your wheels maybe, because maybe the problem's gone on and you're wasting time. And it's really good just to systematically go through and check what it is you know and what you don't know. And agree with, say, your pair or the people you're working on the problem with, like, you know, agree what you're going to do next. It's say, okay, what do we not know? We don't know whether we've got the right privilege to access this database. Okay, I'm going to go and find out that, and then we'll come back, and then we'll have that piece of information. And you should time box that as well. You should sort of say, right, we'll spend the next hour trying to gather this information, and we'll come back to do it. So I don't know if you can see that whiteboard. That's the kind of thing I'm talking about, really, which is just simply, you know, what the problem is, what we know, what we don't know, and things we could take away as actions to try and get some more information to get closer to solving this problem. It's really simple. I find it really effective way of getting to the answer. So obviously we're all aiming for the minimum viable product in what we do. And we know all this stuff, it's quick, so keep the story small, do the smallest thing. As I said before, minimize the sort of defensive programming tendency to over-engineer everything up front and make sure it doesn't do this and doesn't do that. You know, use spikes to prove what you're trying to do. If you are trying to do this thing and you are trying to talk to this new stuff you've never done, then do a spike first and make sure you've got a very simple proof of concept end to end before you actually start trying to write the whole thing, to give yourself some confidence. Make a prototype, showcase it to your friends. Even use the command line, or what I'm trying to say there is, don't go into big script writing or automation or something. Do the simplest thing to prove it. If there's if you want to interact with, who uses Amazon Web Services here? Much, I don't want to, but say you've got these services, you've got something like Terraform as a way of interacting with them. Don't go and write tons of Terraform stuff to interact with it. They do a command line tool, use that, because you can then prove what you're doing. Remember that stories are placeholders of conversations. You know, they're only there to discuss what you're going to do. And that should therefore give you a sort of just-in-time analysis so that you're not over-engineering everything up front. And you should kind of de-scope all the time, because it could be, you know, the story's too big, there's too much going on. You want to do the smallest thing you can possibly do to prove something. As Woody Zool said, like barely sufficient is a good maxim. So technical debt. Who's got lots of technical debt in their organisation? Keep your hand up if you know what it is. The rest of you haven't got any technical debt, is that right? Really? Wow, man. You guys are flying, definitely. I think that's great. So I think all projects accrue technical debt. I think that's true to say. I think if you don't think you're accruing technical debt, you might be, and you might want to have a look and find out whether you are or not. But it's all about knowing what the risks are on a project, yeah. So what we were doing was keeping a tech debt wall. Does anyone do that? Put your hand up if you do that kind of thing. So we found this really useful, because you can't solve all the problems all the time. Maybe it's the first iteration of something, and you don't want to over-engineer. You've written a class to do something, and it's not highly optimized, but you don't know if you're ever going to use it again. So maybe you don't do all that heavy refactoring you're going to do to make it generic and put it out. Maybe you do that the second time, but maybe you write that down. So what we do is keep a technical debt wall, and if we come across anything we're concerned about, then we put it down on there. We just use Trello because it's really easy to just knock something up and use it. And, you know, when we take on the technical debt, you know, you consider that risk. Is this like something that we really have to deal with now? And as I said, you know, don't engineer the future. But the key thing about this is we regularly review it, maybe once every 2 weeks, once every month. we have a look at our tech debt wall and see what's on there, and categorize it, and maybe decide to take the highest risk things that we've decided. We kind of need to sort that out and take that into our backlog and try and resolve it. So here's an example of what it looks like for us in Trello. And you can see we drop things to be categorized in there, and then we've got columns around maintainability, integrity, adaptability, resiliency, security, fast feedback, and viability. So, for example, it says, there are no contract tests around happy path for considered irrelevant in revision. I'm not expecting you to know what that means, but we've got it on there. It's true. It may not really be important. It may never come up, but at least we wrote it down and we say, well, we know that that doesn't exist. And we may never do it, but it's there. It's part of the history of the project. It's almost formed as a part of documentation of the things that are wrong. You see one below, there are no contract tests around rejected revisions. And we reviewed it and we put a little star on it, which is like, actually, we'll take it. That is a problem, and we're going to take it into our next sprint and do it. I said sprint. I try not to say the word sprint, damn. Iteration. I think you should aim for automated deployment. Who's doing automated deployments? Good stuff. It could be a stretch goal. It could be you're in a very siloed organization. You've got sysops, TIO type teams, and this really just isn't possible because they do it and you're not doing it. We were lucky enough to be in a position where we were writing the stuff to deploy our cloud architecture, but that's not always appropriate. You might be on a stack that doesn't permit that to happen, So what it does allow is the developers get to learn the platform. I think, DevOps is a really interesting movement. I don't think it's a whole different discussion, isn't it? But I think the fact that it allows, as developers, to have some knowledge of it, it's not just this sort of black box, you write some software and it runs, and you've got no idea about it. With cloud computing, it's much more possible than it used to be because you're not talking about installing physical servers. We can fire this stuff up very quickly. We can experiment with it. And there's all this great infrastructure of code, stuff like Terraform, CloudFormation, and everything. And it means that you can version control your infrastructure, which is great, actually. And it also means you can instantly get up, if you get it right, new versions of your environment, and they're the same. So you can have a production environment that is the same as your QA, same as staging, same as dev, same as 10 staging environments. They're all the same. You can keep your whole infrastructure up to date. And here's some tools. So we were using Terraform. Anyone looked at Terraform? Deploying infrastructure. So it's really interesting, really good stuff. And we're using Go, which is, I think, of ThoughtWorks. Anyone use Go? It's equivalent to Jenkins. Really good tool. I really like the sort of visual nature of it, the way it just displays. These are sort of deployment pipelines. So we've got a commit pipeline, integration pipeline, and deployment, and that sort of thing. And if you've got any kind of cloud architecture, it makes it very easy to just, with using Terraform, to spin up instances of your servers and all that kind of thing. Okay, so I think the most contentious bit, and I'm going to have to speed up, aren't I? Testers are developers, which is... we were on quite a small project, quite a small team, really, only 6 people. We just didn't have budget or time to have separate testers and developers. I also think that splitting of the resources between, like, these guys are developers, these guys are, why the silos in that? I know people have got different mentalities, but some developers are really good at networking, and they understand network stacks, and some developers are, really love doing test-driven development, or whatever it is. Like, people have different abilities, and I think, the great mindset that testers have to scrutinize things and the attention to detail is just another mindset that a developer can have. So, as I said, it may work better with smaller teams. So if you've got pair programming going on, then a pair of developers wrote the code to write the test, and they write the code. And one of those developers might be the more testy type person amongst you. And then what happens is, the last pair, when you finish the story, doesn't do the QA. You get another pair of people to QA it. And it avoids all those hands-off. So there's no contract between dev and QA then, because the testers are just part of the development team. It's highly integrated. And I think the result I've seen is, because you're going to get your code tested by your immediate peer that you've been on the development team with, and they might be testing your code tomorrow, and you're testing their code, then it actually ups people's responsibility for writing decent code. And also the developers that do the QA, another thing is, maybe you didn't get a chance to pair on that story, where you'll get a chance to see what happened. So it helps with not having to do code reviews or show and tells. It eliminates the need for that. And you get faster feedback, because they're just devs on your team, and often there's no process in between. So I'm going to go quickly now, because I'm running out of time. So know your tool. I said there were a lot of slides and bullet points here. Use your tools, support for refactoring, if it's got it. Learn all the shortcuts that are cool for it. Configure it how you want it, and ensure that you can run tests directly from within your tool. Use the best tool for the code base you're working on. So don't use maybe one tool to do everything if one's really bad at a certain set of code support. I know JetBrains are here, so I will say IntelliJ, I think, is the best IDE out there. And if you're not using it, I would use it, and I'm not on commission from IntelliJ or anything. And insist on licenses. I mean, IntelliJ, I have to say, guys, it's quite expensive. And so often, like, people say, I'm not going to spend 400 quid a year on this IDE for 10 developers. So either JetBrains needs to make the licenses a bit cheaper, or you just need to insist that actually it's really worthwhile spending that money, yeah? Finally, feedback. So just a personal thing, what we were practicing was, does anybody do regular feedback with their colleagues? Yeah? So this is just regularly scheduled time with your colleagues. So we'd sort of say, okay, in this iteration, we're going to have feedback. And the idea of that is you just give face-to-face feedback with your colleagues, yeah, with people you actually work with directly, or other people on your team. Discuss sort of people's strengths, what they could do to improve, and try and use real examples. And make sure you prepare beforehand. So the idea of this is really just to sit down regularly and say, maybe once a month we'll do this. We'll say, you know, here's how I think we're doing. This is when I've observed you do this, and that kind of thing. It's actually a really good way of clearing the air, of understanding each other. Here's an example of it. So someone says, oh, you're really patient with your colleague, and, you know, the result was that this happened, and that's the thing. And, you know, people arriving late at stand-ups always disturb them, and that's kind of anti-pattern, and don't do it. So the outcomes. Here we go. Right, so another project that I was on that we were doing all these practices. We were doing all the practices. The tech lead left for a smaller company. Just wanted to work in a smaller company. We were a big company, just wanted to leave. And we had two other contractors whose contracts happened to come to an end at the same time. And we took on two new developers, one from another team and one from outside. So we were a small team. There was a lot of risk and losing critical mass on our agile practices and what we were doing, and all the stuff with onboarding them was going to slow us down. But what we found doing this was, because we'd done pair programming, the developers that were left on the team had some knowledge of every part of the system. We didn't know everything, but we knew something. We knew it even existed. And often that is the case, you don't know anything. And within weeks, we were able to do a complete handover with our tech lead, who was outgoing, because we already knew something about everything, so we knew what we didn't know. We got a new tech lead and made that transition. And pairing and mobbing, nice thing about mobbing that I found is, and I found this when I came onto the project, from day one, I just sat down and did some production code. Actually added value. It was brilliant. And our code was self-documenting. That kind of helped with things. And all of this helped with onboarding our new members into the team. And it was pretty smooth. It really was really smooth, and we didn't drop any balls. So in summary, in the last minute, adopting Scrum or Kanban on its own, or a hybrid, or whatever you want to call it, Scrumban, Xban, is not enough. it doesn't lead to doing agile or lean software development because they're really ways of doing project management, basically. They're not ways of necessarily doing software development. And XP, all those practices, help you mitigate against producing legacy code, and it helps you write better software. You may not be able to do all of these practices, but just at least do some of them and keep at it, and you'll get there. And that is it. Thank you very much.